my name is Michael Hofmann, and I'm working at Red Hat CKI project, which is doing kernel testing automation. And I'm going to talk a bit how we are testing container images so that they don't break our production system. So just for an overview, so you know when to sleep in this presentation, I'm going to give a bit of an intro what CKI is, just to have some background. Talk about some theory around testing, and then what we needed to do to close some of the gaps that we had and that broke our system. And there, because we only have 30 minutes, there's some appendix to the presentation, so if you're interested, there's some more content at the end related to testing that's not really related to kind. So you can just look it up later, or maybe we get to this. So the CKI is a project or a group of people in Red Hat that are responsible for automating the kernel development and testing process. You can find the docs there, the code is on GitLab. But basically what we do is we run a GitLab CI pipeline like for a normal software project for each push for merge requests. So kernel developers live there, they push, pipeline runs, we build the kernels in AWS, and then the kernels get tested in hardware labs so that they actually work as intended. In the background, there's a message bus running and a lot of microservices connected to this message bus that keep all of this machinery working. And as we do this deployment of this service collection of microservices about 20 to 30 times a day, there's a lot of chance to actually break something, right? Like, so if you do this and you just deploy, right, like what people do, software engineers, right, like they just deploy it, you are kind of expected, or maybe you're not, but you should actually test this. And the testing theory, not that I didn't know it, or not that I knew about it actually in this framework before I started the presentation, but there's a testing pyramid, normally the other way around, with like unit tests at the bottom, which is the normal stuff you do, testing components in isolation. In the middle you find integration tests where you test the interactions of components, and then most services or bigger projects have end-to-end tests that they use to test the whole thing. For example, a next setup or staging setup or something, which is very often manually maintained, so it's kind of slow, but it tests the whole thing. So that's the theory. And at CKI, maybe let's say 2 years ago, we had all of these unit testing going on and we were improving coverage and stuff, so that was working nicely. And we had these end-to-end tests that we had for, I don't know, ages actually. And people were using them, but not really very much because these things are normally slow and you kind of deploy into staging and then you go and look at the logs or do something to figure out whether stuff works. So we had that, but it was not as used as needed, let's say. But we didn't have any integration tests, right? So this stuff in the middle, like in testing components and their interactions, is not that easy to do. So yeah, I mean, right, you can actually test the whole thing and you can test the pieces, or what can go wrong, right? And so over the years we accumulated a number of outages because of this. Now I said it's not that common, right? Like it just breaks once every 2 weeks or something. Right? And this is a collection of what we actually saw from memory. You merge something and you break, it's Python code, right? Like you break a downstream project because something changes, and now all these merge requests are read and people are angry at you because now they can't actually get their code in. Container images don't spin up because you messed up the imports. You misconfigure entry points of container images, and Kubernetes might save you when you deploy this because the new deployment doesn't spin up. You mess up APIs, the configuration file format changed. You can't test the message bus functionality as what I talked about, so yeah, you just hope for the best. And any other interactions, right? Like, so whatever concerned interfaces between services had the potential to break, and it did break. And the way this was done was actually that it was not that easy to recover from these outages, because normally you basically spin a container image and then you had to git revert your way out of it. and it would take 15 minutes to go back to a working version. So with all of this, there are a couple of these that are actually easy to fix, right? Like it's easy, it's not a problem to figure out how to do the easy parts if you just do them. And I'm not going to talk about it because otherwise we're not going to hit the time limit, but these things, what we did about them are at the end of the presentations. So a couple of slides, you can look it up or we can talk about it if you're interested in any of these. But for the other ones, it's actually not that easy to test. And that was the reason why it was untested, right? Like so, when we were talking about this, and yeah, there were a couple of people in the audience that actually remember maybe the times when we were thinking about like how can you actually prevent these breakages. But what it comes down to is actually that it's not easy. So there's something there where you need to think about like how do you want to test container images in a CI pipeline, for example, right? Like so, and this is on the right what we came up with. Like you want to have it locally, it should just work, right? Like you want to do it in GitLab CI or GitHub Actions or whatever. It should, if you're a Python developer, should just look like a normal Python test. You don't want to spin container images all the time. So normally you build a container image, it takes 5 minutes or whatever. So you want to have a fast development cycle locally, so you're not going to have to wait all the time for this to build. And then it's actually interesting if you have such a system, the requirements just come as you go. So you want to have the message bus, databases, other services. You kind of want to have a framework that allows you to kind of model like not a complete end-to-end setup, but a confined integration test setup that has maybe multiple services, the servers under test that you want to test, and then instrument this all from the outside via unit tests in Python, for example. And yeah, and once you start thinking about this, there are multiple ways to go about this. I'm not sure how many people here are responsible for projects that have integration tests. And how many people are responsible for services that don't have integration tests? I won't tell, right? But yeah, so when you think about how to do integration tests, there's one way that's used as long as you're not going for the flexible approach. There's PyTest fixtures that allow you to have a very simple interface to spinning up a database, for example. Mostly just spinning. You might need to have a distribution package installed or something, but it will do something. It will not use container images. But it's very simple for individual cases, and people kind of like it because it's easy enough to do. But yeah, you're most likely not going to get very far if you try. You can spin up VMs, QEMU, whatever. Now that's a whole kind of worm there. It's also not very familiar for people, and kind of like kills the overhead there, right? Like so, waiting for VMs to spin up also doesn't scale that well. Docker Compose. I'm not sure how many people use Docker Compose. Anybody? A couple of people? Yeah, it's what developers normally do, right? Like you can spin up a couple of containers and wire them together, set some environment variables. So that was the first thing that we thought like that's actually maybe a good basis, and I think it's still maybe a good basis for doing integration tests even in one of the Git forges. It's not very similar to a Kubernetes deployment. Our stuff runs in Kubernetes, so the YAML format is different and stuff, but otherwise it would be a feasible way. But what we went with at the end was Kubernetes and Docker, which is, let's say, similar to Docker Compose, just different YAMLs. It's not as familiar for developers that they use any Kubernetes, but otherwise you can basically do everything that you do in production. So we thought might get the job done, right? So what is this, right? Like I'm not sure how many people use Kubernetes here. Oh wow, amazing. And how many people know Kubernetes? No, this is cool. Okay, perfect. Right, like so kind Kubernetes and Docker, the abbreviation is basically running one container per node, right? Like you have a node spins up, and inside of this container you have your pod containers. And it does all the usual shit, right? Like, so it's a single executable you download, and it downloads another node container image. But this whole thing spins up in 20 seconds, and you have a Kubernetes cluster. And it is both, right? Like, it's a Kubernetes cluster, you spin it up. Kind create cluster takes 20 seconds to spin it up. And then you can kubectl your way into it and do whatever you need to do in it. It just works. Looks like a Kubernetes system. But also, if you're going for because it's running in a container, if you're going for Podman, you can just look into, or you see the nodes in Podman, but you can also just exec into these node containers, and you are on your node, right? Like, so it's both, and it's very introspective, maybe even more so than a real Kubernetes system. But yeah, I mean, okay, we have a Kubernetes cluster, but now the next question is actually, how do you run integration tests on something like this, right? Like, so, okay, you can spin up a production system, but if you want to have these properties that we mentioned in the beginning, doing integration testing using such a setup, you kind of need to implement some weirdness. And one of them is actually that you want to have a fast developer workflow. We said, like, we wanted to have our local code, like what we are developing on, exposed in these Kubernetes containers without rebuilding container images. And you start to drill holes into it, right? Like, Kubernetes is really good in isolating stuff. And actually, that's really what we want, but then on the other hand, what we don't really want for these specific cases. So you need to get your files into this. That's doable. So Kind has a YAML format for configuration. You tell it, please, I have a folder here. We expose the whole root volume of your local machine. Let's expose this into the node containers. So that's the first level. And then let's expose this from the node containers onto the pods and kind of replace the code in your service with the local code you have on your machine. It's as soon as you have it, it's obvious. Until you get there, it's a bit, looking for it. And now this is one way of like getting stuff into it. The other thing is we actually want to access what is running in the cluster. If you're thinking about having services running on the cluster, you want to access them. Kubernetes and Docker Kind is made for testing Kubernetes, so you're actually getting this out is again about drilling holes from the pods to the node, which is a node port, which is the first part, and then exposing this from the nodes via Podman to the outside, which is another layer of mapping that you would need to do. But after you've figured out that, it just works. You can even run it not in Docker, Kubernetes in Docker, right? You can run Kubernetes in Podman, no root access needed. You need another system, invocation to get the namespaces correctly, but if you have a developer machine running there, it's accessing not even a Docker daemon and spins up these containers. As said, right, like that just does what it needs to do. If you want to do this in GitLab CI, I'm not sure how many people are familiar with GitLab CI, but if you use GitHub Actions, you get a VM, right? So when the VM is yours, do whatever you want to do. If you do this in GitLab CI, you already are confined to a container, and actually spinning up these extra containers that you want to have for your Kubernetes cluster is a bit involved. So one is that you actually spin up a container with Docker, right? Like, so you have your CI job, and then you have the Docker and Docker helper container. And then this allows you to spin up another container with the nodes of your Kubernetes cluster. So you end up like with 3 containers next to each other, while on your local machine you would have just this one for the node. And then there's various stuff needed to actually make it talk to each other. So one is that you need to expose the Kubernetes API endpoint to your CI job container where you have your Python code running or whatever. And then there's also some certificate stuff going on because there are certificates in various places. But thankfully, somebody on the internet had it figured out. So there's a link there, and very indebted to what he did there, because otherwise it's not that obvious to find. And yeah, the last part is, if you're now going to write integration tests, you actually need to deploy stuff into this cluster, and people most likely use the command line nowadays, kubectl apply or something. Nowadays, with the Kubernetes Python package, that's actually easy enough to do. So it just looks very much like command line invocations. You get a dynamic client, which is the correspondence to when you do kubectl pod or get pod something. You can do very similar stuff in Python with about the same amount of commands, actually. So basically, you're applying some JSON blob into this. So I brought 2 examples where stuff broke, and then we decided let's write an integration test so it doesn't break again. We have a piece of code that's responsible for triggering GitLab pipelines from message queue messages. So you have a RabbitMQ message bus sitting there, and this image is, or like the server is supposed to get messages, do something, and then eventually trigger pipelines in GitLab. And this is what you would need to do for this. You derive from 2 base classes for your Python unit test class. Say like, give me a RabbitMQ server and does this in the background. And please give me also some remote response mocking thingy that we can inspect the GitLab API requests. And once your test method runs, you have these things running. And after your method is done, it kills all the namespaces, all the resources from the cluster. And then you're okay. You need to deploy in the setup method your service under test you want to have. And then basically, the code looks like unit testing code. So if anybody, I would say this is very understandable code. I think I've ever seen something from the OpenStack people. They also kind of had a framework where you thought like, okay, they're bringing up an OpenStack cluster. It was 2 lines. And I think this kind of for us was a similar experience. So basically now integration tests are equally simple to write as unit tests. And the other one is that you have an S3 proxy, which transparently adds authentication. We had a shell script before that was doing this like with some special magic and hand-rolled testing, but now it becomes a very similar thing where you kind of spin up Minio in the background as an S3 server, and then you contact the proxy and the underlying server, and you kind of you put something in the bucket, and then you check that you can actually access it. So again, it becomes very obvious how to do it. And there's more. One of the things that we found it very useful as well is not just for testing container images, but also for testing actually code that is supposed to talk to a service. What you normally do is you mock the responses of the service. Now you just have to hope that your mocking is actually representative of the service, but now you can actually spin up the service. So if you need HashiCorp Vault, just spin it up, right? Like, and you can actually validate that it actually works. Same goes with databases and stuff where you can't really mock anything that easily. So to conclude, once we actually started doing this, and we had something running, it fulfilled whatever we expected from it. It was basically like, let's make something testable that we couldn't test before, and let's make it easy to add new tests to it. Because, okay, maybe getting the first test running even here is a bit involved. Getting all the deployments, like on Kubernetes in general, might be annoying, but adding another test is trivially easy. And it works in CI on developer machines. You need an executable that's big. And it gives you the stuff that Kubernetes gives you, right? Like life cycling, these services, volumes, whatever. It just happens, right? Like you delete the namespace and boom, everything's gone. But yeah, there's a downside to it, which is basically if you don't know Kubernetes, this might not be the place to start, right? So Kubernetes clusters are interesting enough. Sticking them inside of an integration test setup, has another layer of stuff. So if you want to see the code, maybe I lied to you, right? And it's all really ugly, so you can find out by clicking on these links. We have documentation for it mostly. You can see the examples where we implemented stuff for our services. So, yeah. This was kind of the conclusion at the end. But maybe I'm biased, right? So, yeah. That's the main part. So if you want to know more about the simple things we implemented for checking some things, I can go over it. Maybe start with the questions first.
So if you have a question, I will hand you a mic.
Yeah, it's more of a curiosity. I mean, you are a team who deploys services to Kubernetes, so I would assume that developers should actually be familiar with this, at least the basics with YAML and whatnot. So let's call it a learning opportunity instead of a roadblock.
It is, but I think in some ways normally what you do is to split the DevOps part from the development part naturally. So some developers might never have deployed anything, right? Like if you make it magic enough, DevOpsy enough, nobody ever needs to touch the deployment pieces. So I think, yeah, it is still a steep learning curve, I would say, if you've never used it.
Okay, I don't see more hands up, so thank you, Michael, for your presentation.
I mean, we can fill the emptiness by talking about the easy improvements, right? Like, so if nobody has any questions, it's your fault, right? You could have asked questions. I don't mind. So what did we talk about? So there were a couple of things we labeled as easy. And interesting enough, the kind thingy for the complex stuff was far more complicated to implement, let's say, but all the other ones were easy to implement, but we still didn't get them done, right? So it took us a while to actually look into this. And just in case you're actually suffering from some of these breakages in your own project, these fixes are really easy, so they take maybe a couple hours to implement. So one is, if you're breaking downstream projects, yeah, just test it, right? Like, so in GitLab CI, you can spin downstream pipelines. You just need to make sure that your unmerged changes are somehow injected into the downstream project during testing. So that's basically what you need to do, right? Like, so you trigger a dependent pipeline, you pass some environment variable into it, and then you pip install whatever you had there, which is like the usual one, and then you pip uninstall the old stuff, the production version, the one that's somewhere released, and you install your version from the merge request, and then you run your unit tests, right? Like, so this is easy enough to do, but it's also easy enough to not do, and then you break people. And we are dealing with kernel developers. I'm not sure whether there's anybody in the room, but it's recorded, right? But they are grumpy, right? Like, you don't want to piss them off. So this is really useful to keep them happy. The other thing is, yeah, that we really had problems that the container images didn't work, right? Like, now somebody might say, yeah, please run your testing inside of the container image. Yeah, obviously that's a way to do it. But also just trying it out and just calling the entry point and just checking whether it gets as far. It gets you to 95% of all breakages that you normally have there, right? Like, you can just do this, but you need to do it, right? Like, so this is something normally you run your unit tests, you build your container images. This is something you can do after you build your container images and kind of gate these container images based on this. Again, it takes you half a day to do. Yeah, API compatibility. I'm not sure how many people are aware of this pattern. It's called the expand and contract pattern. So at least in our team or in general, people have the tendency to change multiple pieces at the same time, and then you get it all approved. And then you press the merge buttons all at the same time, and it kind of like deploys in parallel, and whatever was incompatible will solve itself after a couple of frantic minutes of stuff slightly exploding. That works. The problem is when something doesn't work, right? Like, and then you need to roll it back. And most likely this rolling back is very often the piece that's then much harder to do. So I don't recommend this lockstep deployment, but it's something that people kind of like feel comfortable proposing in the first place. But this pattern, which is I think well known, is actually that you're providing compatibility with the old consumers. So you're expanding the API to supporting both the old and the new way. You deploy this, you let it settle, you make sure that nothing is weird. You switch the consumers one by one. And then after you're sure that nobody is using the old API, you remove it. It's a very obvious pattern. Still, people don't do it, right? Like, so, but once you explain that to people, they feel far more comfortable actually deploying stuff, changes of this kind. Yeah, and then we had what I said, right? Like, so before we rollback basically meant a git revert, which is the obvious way to do it maybe, but it goes through the whole merge request, merge, approve, review cycle. The solution is basically to hopefully have a good container registry provider that allows you to store terabytes of images. And then you can keep all the images that you spin in all your CI pipelines around, and you can basically switch them in production. So then now basically redeployment is 20 seconds. If you have OpenShift or whatever, basically you retag something or you change a YAML somewhere or do something GitOps. But basically your production deployment is managed by a side channel. It's not directly linked to it. So yeah. So this was, maybe each of those was half a day of doing it. We did it. Okay. So that's all. Go back. Any other questions? Now you can.